Happy? Okay. So thanks, JC, for the invite. And a bit of background is Rao and I share an office, and we haven't quite collaborated on these talks, but fortunately, it doesn't look like there's going to be an enormous amount of crossover. JC sets a fairly formidable task by saying, can you talk about systematic review in a statistical session, but avoid meta-analysis and therefore avoid statistics? So that was a bit of a kind of poser for me. How do you approach that? And the question is, I think you have to go back and ask, what is systematic review all about? And through the design of your systematic review, can you make this a scientific entity? So really, I'll go through that and hopefully not cross over too much with what Rao talked about last night. So we're going to cover what is a systematic review, why are they needed, the pros and cons of systematic review, the key components, and through that, discuss broadly how to do a systematic review. I won't go into a lot of detail about the searches and so on, that may have been done already, and I won't go into how to put it together, particularly at the end. So this is trying to draw out the science behind what a systematic review is. As a fairly stodgy definition, it's a review of the evidence on a clearly formulated question that uses systematic and explicit methods to identify, select, and critically appraise relevant primary research, and to extract and analyze data from the studies that are included in the review. So that's from the Cochrane Library. That's what they think a systematic review is. And by going through this in a bit more detail, we can perhaps understand how we put science into a literature review. We must start with a clearly formulated question. We'll go into that in a minute. Only once you've designed a clearly formulated question, a priori, you must then understand what systematic and explicit methods you're going to use to identify the literature and subsequently critically appraise the primary research. And this is the key. It's how do we take literature that's in the public domain, and some of it quite well hidden, but in the public domain, and critically appraise it and put it together. And only then can we extract and analyze the data and put those into the review. So it is a stodgy and somewhat convoluted definition, but it tells us everything we need to know about how to do a systematic review and how to make it a scientific entity. We do these reviews mainly because we want to answer a substantive question, often in an area where there are several primary studies, but sometimes because there might be uncertainty about the end result. Often these are of randomized controlled trials or of observational studies, but there is a lot of further data out there that if we drill down, we can get and put into such a review. And we all love a forest plot, but as Rao's already alluded to, just coming up with a number and an odds ratio or hazards ratio, if the review itself is done poorly, can either be a poor indicator of the truth or, quite frankly, misleading. So systematic review and meta-analysis clearly overlap, and they sit within a bigger body of evidence that we'll call review. And that includes narrative reviews, traditional literature reviews, and perhaps what we're more used to, the quick and dirty review of find the most junior person in the department, go and ask them to find a bit of evidence, and they come back a week later with 10 references. And I think we need to understand that that is not particularly scientifically robust. And a true systematic review, this seems to be moving by itself. A true systematic review is a much more scientific entity to that. Narrative reviews are usually written by experts in the field, and they use informal or subjective methods to collect and interpret the information. And these narrative summaries do perform a role, certainly, but they tend to be getting across a particular person's bias or a particular person's point of view. They can be used to further discussion, but they're not necessarily scientific or objective. So narrative reviews do depend on an author's inclination as opposed to the scientific approach in a true systematic review. Systematic reviews have criteria determined at the outset, whereas in a narrative review as an author, you get to pick what you want to talk about. Systematic reviews have comprehensive searches for all relevant articles, whereas narrative reviews tend to focus on Medline and Embase. Systematic reviews have an explicit method of appraisal and, where relevant, synthesis. And the methods in narrative reviews are often not specified. And systematic reviews may end up being undergoing meta-analysis, whereas narrative reviews often just say the greater body of papers point towards one argument than another, and often are not replicated if you try and go back through the review. So if we do this properly, systematic reviews can reduce bias, or aim to reduce bias. They're entirely reproducible, and in so doing, in those two facts, they resolve controversy between conflicting studies. They can also be used to identify gaps in current knowledge or areas for future research, and thereby provide a reliable basis for decision making, which includes regulation and funding. I'm sure you've seen this in the last 24 hours. These are the reasons why systematic review sits at the top of our hierarchy of evidence, but only if done properly. Poorly performed systematic reviews, as I said, can be misleading, and we need to understand when we're reading a review what the quality is. Often they require updating by the time of publication, and for anyone who does any amount of review, that can be quite frustrating. You do a year of work and you get it to a point of publication, and as you submit it to a journal, something that changes the argument completely is published by someone else. But that's the nature of clinical medicine. Many reviews fail to include all studies. That's because they're not in English, for example, or not in your native tongue. They don't search the grey literature adequately, and they miss out any early literature, sometimes deliberately, sometimes because it's hard to find. And any quality assessment can still be subjective. So we need to get around all of these problems if we're going to make a proper systematic review that is objective. So the key elements are to developing a structured and systematic process. We must formulate our question, as I said before, plan the review appropriately, undertake comprehensive searches, normally in collaboration with librarians who have specific interests in systematic review, and then perform unbiased selection and abstraction processes, critical appraisal of the data, synthesis where appropriate, and finally interpret the results. And all of these steps must be explicitly described in the review and any subsequent publications. And increasingly, any review must be registered with a database such as Prospero, which also lets you know if someone else is doing exactly the same thing at the same time and saves you from replicating work. So how do we focus a question? This is the most important way to put science into our systematic review. The systematic review should be based on principles of hypothesis testing, and the hypothesis must be conceived a priori. You can't go and look for a question and change the question halfway through. That's not the correct way to do this. And a structured question must determine the inclusion and exclusion criteria, as with any other clinical study. What is the population of interest? What are the interventions? What are the outcomes of interest? And what study designs are appropriate to include? Questions of interest could look at clinical or cost effectiveness. Does the intervention work or not work? Who does it work for? Is it equally efficacious across a number of subgroups or subpopulations? You may look at how the intervention works. Is it appropriate? Is it feasible? And is the intervention and comparison relevant? You can use a PICO technique to try and narrow down a question to an answerable question. So describe the population, identify what the intervention is, use an explicit comparison, and then understand what the relevant outcomes are. Now, I'll run through an example now of how you can take a very time-consuming question and perhaps narrow it down to something that's answerable by using this PICO route. So a question might be, for example, what is the best strategy to prevent smoking in young people? Now, that's almost unanswerable, I'd have thought, or certainly you could spend an entire career trying to do so. You might make that more answerable by saying, are mass media school-based interventions effective in preventing smoking in young people? So already you've narrowed it down considerably. To then work out how you would take that forward to a review, you can put it into a PICO chart. So the problem or the population is young people, say under the age of 25, for argument, it could be 18 if you want. What mass media interventions would you look at? Maybe television, radio, newspapers, billboards, posters, leaflets or booklets, any number that you could specify, but you then limit your review to looking at those interventions. And what is your comparison? There are many ways to look at how you might reduce smoking levels, but our question is this is a school-based intervention. So these interventions listed in the second column taken into a school environment. And our comparator is against no intervention at all. The outcomes in this case can be objective, maybe self-reported smoking behaviours, or intermediate measures such as measured attitudes. And then we want to understand what types of studies we're going to limit it to. In this case, are there any randomized controlled trials, or controlled before and after studies, or time series designs? So it doesn't matter what the topic is in particular, but if you go through this process, you'll inject science into your review and you're more likely to come up with the correct answer. You then have to underdo comprehensive data searches, and this is where systematic review lives and die really. The searches must have a clear research question. The searches must look at all domains, have no language restriction, include published and unpublished literature, and be up to date. And the document searches must be reproducible. You won't be able to read this, but this is a review that I've performed recently for the health technology assessment. And this is a search strategy purely for Medline, for one of the clinical outcomes. So this is a clinical effectiveness search strategy, and this is the cost effectiveness search strategy. This needs changing for every single database you look at because search terms are different. And it's by using these, what appear to be quite convoluted by all accounts, strategies that you're going to narrow your searches down from thousands of articles to the correct data that will allow you to start looking at the correct literature. As with a randomized trial, there are flow diagrams that you can use to then understand the flow of literature through the review process and understand where the scientific evidence is coming from. This is my same study. We started out with around 5,200 studies, a large number with duplicates. And you can see you go through an abstract review process and then a total review process looking at the article in total detail, trying to find any additional references, and we ended up with no studies that were relevant to this review. And was that a negative review? Well, it was until you look at the flow chart, but in fact it gave us a great deal of evidence that there was no significant literature looking at what is a hugely important topic within vascular surgery. One of the biggest operations, commonest operations we do, there is no evidence about. And I think that's an important finding in its own right. So in summary for study selection, we're trying to minimize bias, and studies should be assessed for inclusion using selection criteria that flow directly from the review question. You ought to pilot these and check that they can be reliably applied. Study selection is a staged process that involves going through citations located by the searching. It's time-consuming, but if you do it properly, you'll get the correct literature. And parallel independent assessments by more than one researcher should occur in order to minimize the risk of errors and also minimize bias. And the study selection process should be documented, detailing the reasons for exclusions or near misses. So we've got our hypothesis, we've done our searches, we've looked at the papers, we've got our small group now, we're going to try and get the data out. But before we go for the numbers, we have to look at critical appraisal. We must critically appraise the relevant primary research and understand whether there are differences between the papers that could answer why there are different results. Because not all published or unpublished literature is satisfactory. Just because it's in a journal doesn't make it sound. And the onus is on whoever is doing the review to understand whether those data are valid or not. And the difference in quality, as I said, could be an explanation for the differences in study results. You can guide the interpretation to the findings. It can rather guide the interpretation to the findings and aid in determining the strengths of any inference in your study conclusion. So there are any number of ways of doing this quality assessment. There are more than 35 different quality assessment instruments that are published. Some are very good, some are less good, and different people, different authors have different strengths of feeling about whether you should use a numeric score or a more descriptive score where you just list or assess the various aspects of individual trials. The commonest way is using a composite numerical scoring instrument such as the Jadad score. This gives 2 points for randomization. 1 point if a study is described as randomized, and a further point if randomization methods are described and appropriate. You can take a point away if the randomization scheme is described but poor. There are then 2 points for double blinding. You can add a point if the double blinding method is described and appropriate, and again deduct a point if it is inappropriate. And if there's a satisfactory explanation for withdrawals or crossovers, you can give a further point. This is an example of the Jadad score, 5 studies of various different qualities. So the one on the top has excellent description and appropriate randomization. It probably had a poor discussion of blinding, but a good description of what happened to the patients. Compare that to the last study, study 5, which either wasn't randomized or had a poor description of randomization. They obviously went into a deal of description and had appropriately blinded participants and had some sort of description about dropout. So this is just an example of one score. There are many, many types of score, and I think the important point is you need to think of some way to quality assure the studies as opposed to focusing on you must use this score or that score. This is taken from the York group, who have significant and lengthy expertise in systematic review and meta-analysis. And as I said, they feel that the use of quality scores is problematic down towards the middle of the paragraph there. They say it's preferable to consider individual aspects of methodological quality in the quality assessment and synthesis. But despite this, the commonest way of assessing quality is through these numeric scores. So only at this point can you go on to data extraction, and you'll be a long way through the review process by this point. Even at this point, you must have a standardized data extraction form with dual independent data extraction, an understanding of what you're going to do where there are discrepancies between the two people extracting data. And if you're going to design a data extraction form, you want to understand what your primary and subgroup analyses are and just do data extraction once. It's very frustrating to have to go back and redo the whole thing if subgroups have been missed. And this must be unbiased and reproducible, and I would add published along with the main paper. This is an example of the sort of information you might put into a data extraction pro forma. So you want general information about who's collecting the date of data extraction, and identification features of the study, any study characteristics and participant characteristics of relevance. You then look at the intervention and setting, and then look at the data outcomes and results. So it's not rocket science, but it needs to be done ahead of time in order to prevent you having to go back and do this repeatedly or missing key data. And then a brief closing comment on how to present the results. There are endlessly evolving checklists for systematic review and meta-analysis. The PRISMA checklist is kind of well validated and well accepted. It covers 27 points. And if you go through the flow diagram and if you go through the checklist, that is essential to ensuring a high quality review. Again, you won't be able to read the text on this, but this is from my recent review. This has to be published along with the review details, and you go through each point, say where you have commented on each point, and make any notes against it. If there are significant deviations or significant contributions outside the main text, you need to include that in an appendix, such as the search strategies, such as your quality assessment, and such as your data extraction form. And if you go through all 27 points from having had a proper hypothesis at the beginning, you'll make sure that your review doesn't include significant bias and is entirely reproducible for anyone who wishes to do so. And finally, when you've done all that, you can put the paper together. Don't try and do anything different. Follow a conventional structure. Be clear and comprehensive. Anything you've done should be reproducible. And I'd say check with your target journal, 'cause it's very easy for these to be long. That review I've cited on the way through was the best part of 200 pages, but the journals might want something a bit shorter. Okay, thank you.